morning everyone. So students, in the previous class we discussed about the meter bridge. Yes. So today we will take the next part, that will be the potentiometer. Yes. See, distance bridge, meter bridge and the potentiometer, these are the instruments we are using to measure the current or else the resistor or else the length. Yes, length of that wire. Like this, we are using the different instruments to measure the internal resistance, then voltage, then resistance, like this. Yes. So today we will take the last part of your lesson, that is the current electricity, that is nothing but the potentiometer. Yes. So what is this potentiometer then? See, the potentiometer is a device used to compare the EMF of two cells and to measure the internal resistance of the cell. So, see how the meter bridge is having the one diagram, no? Similarly, it is also the having one diagram, correct? So that you will do in your practicals. Yes. So it is also one instrument where we are using this potentiometer to measure the internal resistance. Yes, and we are comparing the EMF of the two cells. Yes, here they mentioned the potentiometer is used to compare the EMF of two cells and calculating the internal resistance of the cell. Correct? So this is a potentiometer. Then on what principle this works? Yes, see, when a constant current is passed through a wire of the uniform area of cross section. See, just you consider the one wire here. Yes, take it as wire. Yes, see, we consider the one wire that is having the uniform area of cross section, that is nothing but the uniform. See, this the area wire will be the uniform throughout the wire. Just consider this as a wire, so it is uniform now. Yes, here it is not bigger and here it is not lesser, correct? It is having the uniform area. Yes, that is only I am telling you. It is having the uniform area of cross section, and the potential drop across the any portion of the wire is directly proportional to the length of that portion. What is it? See, at this point there is a drop of potential, that is nothing but the voltage. Yes, see, this is the wire and it is having the uniform area of cross section. If at this point the voltage decreases or else increases, yes, potential drop is nothing but the variation of the voltage. Yes, see, just consider at this point the potential drop decreases. Yes, there is a potential drop, nothing but there is a variation of the voltage. Yes, so this point, yes, there is a potential drop which is directly proportional to the length of that portion. How much it is now? This is the length, correct? So first it was having the length this much. It's this much. Take it as a L length. How much? Capital L I am considering just for understanding purpose. So first this wire is having the length of capital L, but now at this point there is a potential drop because of the some conditions like temperature, pressure, and there is a mistake in circuit connection. Because of that there is a potential drop will occur here at this point, right? So now whatever the potential drop occur at this point is directly proportional to the length of this portion. Yes, length of the portion of this wire, right? So this is on this principle the potentiometer works. Yes, see, you have the practical on this. There you will understand it better. But just for the information purpose, I am telling you this one. And here I will give you the diagram in the video. Just draw that one. Okay. Now we are moving towards the theory of this potentiometer. Here you have the one small derivation. Yes. So let V be the potential difference across the certain portion wire whose resistance is R. Yes. What they said? V will be the potential difference. Yes. So instrument is having the potential difference of V across the certain portion of the wire. So see, through this portion there is a potential difference is present. Yes. Now the resistance, how much they are having? R. See, V be the potential difference, R be the resistance, and I is current passing through that material. Yes. So here we consider the one wire. In that potential difference V is present, resistance R is present, and the current I is flowing through that. Understood? So now we know that already the Ohm's law, what it is? Potential difference is directly proportional to the current passing through that material. Correct? That is nothing but the Ohm's law. Here V is equal to IR. What I said? Potential difference is directly proportional to the current passing through that. Yes. So if I remove the proportionality constant, what we will write? R. Resistance we will write. Yes. So that is nothing but the V is equal to IR. Ohm's law. So first consider the Ohm's law here. Then afterwards, yesterday I told you one point that just Google the resistance and the resistivity. Yes. So here now you understand the resistance is. So resistance of the material, that depends upon the two things mainly. Yes. What are that? One is the length of the material and second one is the uniform area of the cross section. What it is? Uniform area of the cross section. I think for this we derive the derivation. Yes, after the Ohm's law. Correct? So now the resistance will depends upon length of that wire and inversely proportional to the area of the cross section. Correct? So in order to remove the proportionality constant, we put the one constant, that is nothing but the resistivity. Yes. So now we can write resistance as R is equal to rho. See, this is nothing but the resistivity. That symbol will be rho. Yes. Rho into L by A. Then we can easily write now. See here, V is equal to IR. Yes. Just what you do, put the value of R in this equation. Yes. Here I will write. Put R in equation number 1. Take it as equation number 1. Yes. So put the value of R in this. Yes. So what you will get here now? V is equal to 5 into L. Why? Because I into rho by A. What it is? This I rho, this one rho into A. This all the terms here. This I will write. What is? V is equal to I. R is how much? Rho into L by A. Yes. So now this then whatever I made the I into rho by A. Yes. See, first we consider the Ohm's law. V is equal to IR. Afterwards, the resistance is the rho into L by A. Now, you put the value of this R in the equation number 1. Yes. So, what will happen? That much we will get. Last one. V is equal to I into rho into L by A. Yes. So, now, see, V is same, V is same, L is same, L is same. But only this box I replaced by the term phi. Yes. So, phi is nothing but the I into rho divided by A. Correct? So, now what will happen? V is directly proportional to this phi value. Now, what is this phi then? Yes. Phi is nothing but the potential gradient. What it is? Phi is called as the potential gradient or potential drop per unit length. That means I told you no, here at this point the potential drops. Yes, at this point the potential drop. That's why this value only we considered it as phi. Yes, so phi is nothing but the potential gradient or else the potential drop per unit length. Correct? So, we can write it as V is directly proportional to phi. Yes, here V is equal to phi L we have. But now I want to define the potential gradient. So, what I will do? Equal to phi I will consider and V, this L will be comes in the denominator. Correct? So, now you can easily define the potential gradient. What it is? Potential difference per unit length. Yes. See, V is nothing but the potential drop. Here we consider V is nothing but the potential difference. Yes. Potential drop it is and divided by per unit length. Yes. That is nothing but the potential gradient. Yes. So, this is the formula for the potentiometer. Correct? So, this is the theory what I want to discuss with you for the potentiometer. Yes? So, after this you are having the two applications for the potentiometer. Yes? These application only you have like a practicals. Yes? That is nothing but the experiments you have. Yes, as the applications of the potentiometer. Yes, what are that then? See, the first application of the potentiometer is comparison of the EMF of two cells using the potentiometer. So, we are comparing the EMF of the two cells. See, here one cell is present and here one cell is present. So, cell 1, cell 2. So, I am comparing the EMF of these two cells by using the potentiometer. It is the one experiment for you in the practical. Yes. So, we get the formula here. E1 by E2 is equal to L1 by L2. This you will do in the practical. There you will understand it better. How we will make the circuit connection and how we will apply the principle of the potentiometer there. Okay. So, here we will get the one formula. Ratio E1 by E2 is equal to L1 by L2. See, the potentiometer means, of course, the wire is present. So, length of the wire we will take. Then, L1 and L2 be the length of the wire. Yes. Then, by using the ratio of this, we are calculating the ratio of the EMF of the two cells. Yes. So, E1 is the cell 1. Yes. EMF of the cell 1 and whose length will be how much? L1. Length of the wire is how much? L1. And E2 be the EMF of the second cell and having the wire which is having the length is L2. Yes. So, measuring the L1 and L2, the ratio of the EMF of the two cells can Understood? This is the first application of the potentiometer. Yes. Then afterwards, the second application, that is determination of the internal resistance of the cell. So, the potentiometer we used to determine the internal resistance of the cell. Yes, that we connected in the circuit diagram. Understood? So now, what is the formula here? Small r is equal to capital R in the bracket L1 divided by L2 minus 1 in the bracket close. So here R will be the small r will be the internal resistance, as we already discussed about this EMF internal resistance, S and the cell. In that combination we discussed about the EMF internal resistance and the cells. Yes. So capital R will be the resistance of the cell. Correct? And in the bracket we are considering the ratio of the length of the wires L1 and the L2 minus 1. Yes. By using this value, and see, behind doing the practicals, first we measure these three values. Yes. So we will get to know about the resistance R, L1 and L2. And we are putting the value in this equation. So easily we can calculate the internal resistance of the circuit by using the potentiometer. Yes. So we come to know that the potentiometer, how it works and what are the application of the potentiometer. Yes. So students, this completes your chapter current electricity. Yes. So today I will take the one problem on this and we will solve that one. Okay.